Hello students, here's another edition of Helpful Hints. Chapter 11, problem set number 2. This is problem 31. So here we have a 0.4 kilogram ball is shot directly upward at an initial speed of 40 meters per second. What is its angular momentum about P, 2 meters horizontally from the launch point when the ball is at the maximum height? Halfway back to the ground, what is the torque on the ball about P due to the gravitational force when the ball is at a maximum height and halfway back to the ground? This is a great problem because you really have to think about things. The juxtaposition of this ball relative to point P and the velocity vector, such that you satisfy the angular momentum for a particle. Let me at least say as much, is that the angular momentum for a particle is equal to r cross p. Okay? R is a vector, momentum is a vector, angular momentum is a vector. But the quintessential idea here is that r would cross with p. It's not the m so much, but it's the velocity vector. Okay, so those two need to be perpendicular to one another to satisfy the relationship. Okay, so check this out. This ball is going to rise, and then it's going to reach a maximum height. So for part A, if the ball reaches maximum height, what's its speed? Okay, that's all I'm going to say about that. It should be obvious. So at max height, its speed is, all right, I'll say as well. All right, 0. All right, so what's that say about the angular momentum of the particle when it's at the maximum height? Okay, that's all I'm going to say. Let's take a look at part B. All right, part B, half the way down. So this particle is going to start moving from its maximum height, half the way down, and half the way down, it's going to have a speed. Okay, it's going to have a speed. All right, and what I'm going to ask you to do, this is on you, to determine the speed of this particle where it's fallen half the way down. So you're going to have to figure out the maximum height, divide by 2, and then let it fall that distance. And whatever speed it has, having fallen that distance, that'll be your velocity vector. But here's the point. All right. So I'm going to draw a line from point P to the location of the ball. Okay. And let's make this somewhat faint. So this is your R. All right. That's going to be R. All right. So geometrically, that's going to be your distance. Now know that point P and where the ball was launched, that's 2 meters. All right. The height that it came down, half the maximum height, okay, that's on you. Okay, whatever that distance is. So with some fancy geometry, you'll be able to determine stuff, specifically the angle. Okay, perhaps the angle that this velocity vector downward makes with respect to r. So I'm going to leave this up to you, but drawing the diagram, notice that I'm just going to make a little bit of a velocity vector. Notice that vector, that's going to be your perpendicular velocity. I'm just going to change that. All right. So that's going to be your perpendicular component. That's important. So r cross f. So r times the perpendicular component of the velocity at that point. All right? Okay. Part C. Now, part C, what's the torque? Now, torque is defined. Okay, so for part C, torque is defined as r cross f. In this case, the gravitational force. All right. Now, if you look at the direction of the velocity vector, that's also the same direction on the way down. And it's also the same direction as the gravitational force. So what you've learned and have applied in part B in terms of turning that velocity vector into its perpendicular component to the radius, the distance from P to the location of the particle on the way down, you should be able to figure it out. So that's your suggestion for number 31. All right. Have a good evening.